Love me 2 times, baby. Love me twice today. Love me 2 times, girl. I'm gone away. Love me 2 times, girl. 1 for tomorrow, 1 just for today. Love me 2 times, I'm gone away.
Okay, so yeah, we're going to be covering recursion. And so that's where you have something like a method that calls on itself. That's where you have something like a method that, you want to like come closer or something? A method that calls on itself. So an example of this would be, there's an acronym, GNU, and that is some software, and it stands for GNU is not Unix. So like you can see that within the acronym, it uses itself. So like if you were to then take this, you'd get GNU is not Unix, is not Unix. And then you can keep going.
Does it just keep going on?
It would just keep going on.
Not Unix and then keeps going.
Yeah, although in the program that we're going to be doing, we're going to have it end at some point. One example where you can use something like this is in with the Fibonacci sequence, which we did before. Before we had to use 3 variables to hold the previous 2 numbers and then 1 to hold the sum. So you'd have int x, y, z. Actually, need to have these. 1.
Figure out how it goes together and just stuff it. It's like 2 seconds. So the major layer, the bottom layer first, top layer, okay?
And then
use connect 2 sides together. And so you can just do it. It's just make it and use it to make it. But figure out how to combine together.
So if you put that on the top, it'll print all the Fibonacci numbers. It would be 1, 1, 2, 3, 5, 8, 13, so on and so forth. So each number is the sum of the previous 2. So 3 is the sum of those 2, 5 is the sum of those 2, so on and so forth. And this is fine. This will just give us all the numbers from the first term, second, third, fourth, fifth, all the way up to 100. But what if we want, say, the 50th term? I should write this over there. Say we want the 50th term. In this case, we'd have to write all this code, which is kind of annoying. What we can instead do is use something like this, where the method calls itself to get that number. So I'm going to erase this. So let's write a method called fib for Fibonacci. So it's going to return an integer, which is the number over here at the nth term. And then we're going to give it an integer, which is whatever term we want. So we'll call it just n. And then in here we have to do something to find the Fibonacci sequence. So the first thing that we have to do is check if it's one of these two terms, because those are our givens, and they're both 1. So we'll say if n is 0 or n is 1, we'll start from 0 because most places start from 0. So we'll change this to the 0th term, the 1st term, 2nd, 3rd, 4th. And then we'll just return 1. Then we can say I'm not sure if the camera can see that. We return the previous term plus the term before that. So you can see that this method calls itself. And if we go through this method, say we put in 3. So we come in here with 3. This is false, so this doesn't run. And then it will do this method on 2, and then this method on 1. So that will say, what is it? So this will be, this will become 1, and then this will go through again, and we'll say fib of 2 minus 1 plus fib 2 minus 2. So then this will become 1, this will become 1, and then this will also become 1. So then if you add these 3, you get 3, which we have over here. So we should look closer at how exactly this is working. Ignoring this part for now, we'll say the nth term is the previous term plus the term before that. So it would be a of n equals a of n minus 1 plus a sub n minus 2. And so this is like the kind of series that you'd see in, I think, kind of. It's a little bit different. Since it's not an equal difference each time. Yes?
Do you have to tell it to allow a GNU, or does it just does?
Wait, this part? Oh, this is just an example. So, if we were to come in with any number, it would take that number, say a sub n, and say that is the sum of the a sub n minus 1 plus a sub n minus 2. So in this example, if we wanted, let me rewrite this. If we wanted 1, 1, 2, 3, if we wanted this term, which is the third term, then we'll say this is the sum of that one and that one. And then that would be this line. And then we can say this part is just fib of 1, and we already know what that is because these are our givens. So we just replace it with 1 here. And then we say this one is the sum of that one plus that one, which is what we're doing here. And then each of these is 1 and 0, and since those are both our givens here, we can just add them together. And then if we put in, say, 50, it would give us the 50th term, and it's not as long as the other example. It's a bit harder to understand if you just look at it, but in some cases you'd have to use recursion. Let me see. Usually you only use recursion if you have some sort of structure that has structures within it. So like if you had, if you're doing some sort of graphical thing where you had a box and then you need to subdivide it into 4 boxes and subdivide each of those into 4 boxes and then so on and so forth, and then you wanted to draw all of those, then you'd say, you tell this one to draw itself, and that would call that same method on its 4 sub-boxes, and then each of those would call that method on their 4 sub-boxes, which would end up drawing every single box here. Yeah. So, yeah, you can go now. Okay, that is recursion. Any questions? Okay. Yes.
50th.
Yep.
What do you write in the console to tell it to write?
You just do.
These are your parts. Right?
Okay, so I'm gonna erase this now. So now,
Love me 2 times, I'm gone away. Love me 2 times, babe.